Hi everybody, it's Miss Austin. I'm going to be doing the lesson 2 practice problems in unit 2. Number 1, line SD is a line of symmetry for figure AXPD-ZHMS. So this is your line of symmetry. Noah says that AXPDS is congruent to HMZDS because sides AX and HM are corresponding. Why is Noah's congruent statement incorrect? Okay, even though those two sides are in the same location and they are congruent, the order of the letterings is incorrect. Okay, so look at the way Noah wrote it. He said, I'm going to write Noah's right by, and we know this is the line of symmetry, right? So A goes to M. So when you look at this, A, that should be M. X should go to H. See how this doesn't line up? I mean, he had the idea right, but I think he didn't put them in the right order. So even though those two sides are corresponding, okay, we know that angle A has to go to angle M, or point A has to go to point M, and he does not have those two lining up. So we could say angle A goes to angle M. Not, he has it going to H, which is way down here. Write a correct congruent statement. Now there's lots of choices here because you can say the first one however you want. So I'm going to say the first one the way he did. So AXPDS is congruent to, so we started here and we went down, so I'm going to go MHZDS. MHZDS. Same exact order. Okay. Figure MBJKGH, that's this one right here, is the image of figure AFEKJB, this one, after being rotated 90 degrees counterclockwise around point K. So if we want to envision that, so they went counterclockwise, this way, sorry. Boom. Okay. Draw a segment in figure AFEKBJ, that's this one, to create a quadrilateral. So I'm going to go right here. It's not the only way. You could have went this way. Draw the image of that segment when rotated 90 degrees counterclockwise around point K. So now I'm just going to use that same shape. So here's this new image, right? Or sorry, this new segment. And I want to put that in this one. I'm going to go 90 degrees counterclockwise. That's going to be right there. Write a congruent statement for the quadrilateral you created in the figure and the image. So I've got more than one choice here because I basically broke this into two quadrilaterals. And I'm going to have to put a new letter here. Do I have to put a new letter here? Let's see. Draw a segment to create. And I'll call this C. And I'll call this X. Okay? So now I want to write a congruent statement. I'm going to do this one right here. So CKJB, CKJB is congruent to. Now it sort of gets confusing. If you wanted to, you could put the letters C, K, J, B. I'm going to re-rotate that 90. That's this one over here. See that? Now look, C lines up with X. K still lines up with K. C, K. J lines up with G. And B lines up with H. Now that is not the only way. There's other possible answers. I could have done those two quadrilaterals. All right, moving on. Number 3. Triangle HEF is the image of triangle FGH after a 180-degree rotation around point K. So if you want to see this, oops. So that one down there. Select all statements that must be true. Well, that was a rigid transformation, which we know preserves distance and angle measure. Triangle FGH is congruent to FEH. Let's see, did they say it in the right order? Ooh, gotta look at these points. FEH. F goes to H. So that is incorrect. They did not say that correctly. Let me make sure Miss Austin didn't mess up on this. Round 3. Yeah, it's from the wrong location. The letters don't line up. Triangle EFH, and they already told us up here the order of the letters, right? We can scramble those up, but they still have to line up. EFH is congruent to GFH. Well, does G go to E? Yeah. You could also rotate it here and see if they lined up. And then what's the next one? F goes to H. No. So they said the next letter is F, which should go to H. And this one says GFH. Those letters are not in the right order. Angle KHE is congruent to angle KFG. KFG. This one might be easier to see if we rotate. Let's look. Yes, it is. Angle GHK, that's this one, is congruent to KHE. That one right there. Hopefully you already know the answer to this. If I rotate that, that's going to go over there. No. Segment EH is congruent to FG. So that's this one. But we also have to make sure they say it in the right order. So they said EH goes to FG, yes. And segment GH, that's this one, is congruent to EF. And I'm going to kind of show you how you don't really have to use the transformation. You can just look. They originally gave us this statement right here, right? So that's the order. I can tell H corresponds to F, E corresponds to G, and F corresponds to H. So now let's look. GH, that's the second two, go to EF, the second two. That is correct. They're in the right order. All right, number 4. When triangle ABC is reflected across line AB, the image is triangle ABD. We did this one, I think, in the lesson 1 practice problems. We created this. If I reflect that across here, I've now created this new triangle ABD. says, why are segment AD and AC congruent? Okay, well, this is a rigid transformation, so these two triangles are guaranteed to be congruent, this one and this one. And I know that AC corresponds to AD, and corresponding parts of congruent figures are congruent. If that corresponds to that, and I know those two figures are congruent, then those two sides have to be congruent. All right, number 5. Here, Elena needs to prove that triangles BED and BCA are congruent. Provide reasons to support each of her statements. First, she says that line M is parallel to line L. How would she know that if they didn't say it? Well, notice these two angles that they gave them, right? Two parallel lines being cut by a transversal, those are corresponding angles. If corresponding angles are congruent, that means those two lines must be parallel. Since angle BDE and angle BAC are corresponding and they're congruent, the lines must be parallel. It's kind of like the reverse. If I tell you the lines are parallel, then you know these two angles are congruent. Well, now think about it. Now that I know these two lines are parallel because of those two angles they gave me, adjust your eyes over here. These two parallel lines being cut by this transversal, then aren't those just corresponding? So since line M is parallel to line M or L, angle BED is congruent to angle BCA because they're corresponding. I'm ran out of room. I'm gonna have to do it over here. They're corresponding angles. And the lines are parallel. How do we know the lines are parallel? Because those two corresponding angles were the same. So I used first, oh my goodness, those corresponding angles are congruent. Those two lines must be parallel. Now that I know the two lines are parallel, well, these corresponding angles over here must be congruent. All right, number 6. Triangle FGH is the image of FEH after a reflection across the line HF. Select all the statements that are a result of corresponding parts of congruent triangles being congruent. So I know if these two were the same here and that's a reflection, then these two are the same here, right? And F goes to F. So this is the same as this. I'm just going to mark these up right now. These two angles are the same, and these two angles are the same. Here we go. EFGH is a rectangle. I don't know anything about those angles except that, those are congruent. I don't know if they're 90. EFGH is a rhombus. Yes, all four sides are congruent. Diagonal FH bisects angle EFG and EHG. Yes, because since these two are the same, that means this right here cut that big angle in perfect half. Same over here. Triangle FH is perpendicular to FE. Diagonal FH. So is this diagonal perpendicular to this? That doesn't look like it meets at a 90-degree angle. Or do I have any evidence of that? Angle EHF is congruent to EHF to FGH. FGH. That one to that one? No. FEH, this one up here, congruent to FGH. Yes, those two go together. All right, guys, I hope that helped. I'll see you soon.